Hey guys, today I'd like to talk with you about finite state machines. Everyone should know by now, but they're one of the best tools in a game dev toolkit, and I always have this sort of imagination where for me, a finite state machine is nothing but a storyboard that will be used to describe behavior. And I want to give you this example. It's very small, but it's only to demonstrate some real use case. And in this zombie's storyboard, there's a subtle pattern. The zombie walks and then he hits to enter his cooldown after hitting, where he stays idle for 2 frames, only after he started walking that he could hit again. And when you read a storyboard, you start from the first frame, then I update my thoughts and feelings about it to finally decide if I want to watch it for longer or move on to the next frame. Then of course, you do it for all frames until you're satisfied and all is good. It's an easy interface to convey behavior. It tells a little story that's sometimes much easier to pick up. But okay, what does it have to do with finite state machine? Let me rearrange the storyboard. Assuming we have some repeating behavior, we can get rid of duplicate, and now we can specify their behavior by their transition. And now we can play this finite state machine the same way we were reading in the storyboard. Walk, then hits, but now you can see by the transition, after hitting, it can only rest in idle. And then of course when it walks, it can hit again. But now guys, I wanna outline what the code looks like. And I'm using Defold, so all the examples are gonna be in Lua, but it should apply for Love 2D. And of course you can check all of the source code in the description. And if you guys want, I can release a TypeScript version I have as well. Let me know in the comments. And to start off, we need 2 objects, one for the finite state and the other for the machine. When I say object, it just means properties and methods. So it can be class or a struct because it doesn't use inheritance. For the state, we're gonna need a name and some callbacks for enter, update, and exit. Also, similar to when we wanna move to the next frame on the storyboard, we need a predicate function. Okay, so now we have a predefined lifecycle, and now we can bind context to the state so we can know how to act, and it's good to go. For the state machine, we're gonna need all states, the current state, a transition initializer, and a start initializer. After we have all transition information and all start information, we can start updating the finite state machine. And this should be all we need actually. But I want to go further and talk about something that is very left out in the finite state machine discussion, which is developer experience. Because when we start designing dozens of states, we want to make it very approachable. So I always like to have this abstraction to help me create the state. I prefer this over inheritance because composition scales so much better to larger code bases, and I have no reason to push Lua into using inheritance. So the builder will have every property of the state, but as a function to initialize it. And I want to give some attention to this predicate to function, which is a helper function. So you can decide individually between states to move on. So we can have a check for each neighbor state. And now we can see how we would actually call these functions. So first I define an object of states. Here is where you would set up all the playing animation functionality. In this case, it just prints out that it's playing. In the walk, you can see we update as well. And to define this machine, I just transition to idle and back to walk, starting at idle with a certain speed. And finally, I can update until its lifetime is done. And now I want to show you some examples of some real uses I got in my game. I left all the bug information available so you can see each agent state above their head. So the chickling, you can see how it goes from following its route into attacking, and it doesn't like getting too close to its sisters. So it detects clumps and it goes into the too close state to avoid it. Now onto the bot, and in the former bot, we can see that he will farm, and for each attack he will back up, like he's kiting. If he is low health, he will also back up. If he is losing the skirmish, he will also attempt to back up, but otherwise he will try to farm, and if you get too close, he will attack you. After he's done farming, he will try to escort his minions close to your barn, and after that he will try to end it. He's ruthless. Yeah guys, fsms are dope. but I want to hit you with some use cases. Like you can use it for cutscenes, tutorials, character customization, or really any player interaction. Heck guys, you can make a state machine of state machines and call it an orchestrator. You know, you can be the director of your own movie or something. That's about it guys. Check the description for the code. Please consider helping the channel and I'll see you in next update. Super.